Good morning, my YouTube viewers. It's Crystal here. This is the third time I've made this video because I'm having some problems with my computer. My computer is 6 years old. I think I'll probably need to get a new one when I get the money. But in this video, what we're going to do is we're going to talk about confidence intervals. And confidence intervals are something that's used in statistics. And they give you the lower value and the upper value. And so all your data should be between that lower value and the upper value. So what we're going to do is we're going to go through some practice questions on confidence intervals to give you a little bit of insight into how to calculate confidence intervals. So the first practice question we have is we're going to simulate a sample of 40 observations from a normal population of mean 70 and standard deviation of 10. We're going to compute 95% confidence interval for the population mean, assuming sigma is known. So sigma is your standard deviation. We're going to be using the R programming language to calculate these confidence intervals. So I'm just going to delete that, give us a little bit more space. So the first thing we want to do is we want to set our seed. And what happens when you set the seed is that every time you run the cell, the variables will be set up, will be initialized to the same value. So that's why you want to set the seed. So set.seed brackets 1, 2, 3. And then what we're going to do is we're going to define our x variable, which becomes our norm, which is a normal distribution with random values, brackets 40, that's your number of observations, comma mean equals 70, comma SD, that's your standard deviation, equals 10. And we're going to calculate the x bar becomes the mean of x, and sigma is your standard deviation, becomes 10. N is the number of observations, becomes the length of x. CI is your confidence interval, becomes x bar plus c. We're going to create a vector, brackets -1, 1 times 1.96 times sigma divided by the square root of n. And then when we're going to show our confidence interval, which is 67.35 to 73.55 after we have used the formula. So we're going to plot it. So plot brackets x comma rep, that's going to create a vector, comma 1, comma length x, comma PCH equals 19, comma color equals blue, comma x lab, that's your label of your x-axis, equals values, comma y fab equals null, comma x y axt equals n. And main, which is your title, is 95% confidence interval reproducible. So we're going to put some lines in the graph. So AB line, brackets V equals x bar, comma color equals red, comma line width equals 2, comma LTY equals 2. And then we're going to put another line, AB line, brackets V equals CI, that's your confidence interval, comma color equals dark green, comma line width equals 2, comma LTY equals 3. And we're going to put some text in the graph as well. So text, brackets x bar, comma 1.1, comma mean, comma color equals red, text, comma CI, square brackets 1. So that's the first element of the confidence interval, brackets 1.1, comma lower CI, comma color equals dark green. And then text, bracket CI, square brackets 2, that's the upper end of the confidence interval, comma 1.1, comma upper CI, comma color equals dark green. So we're going to run the cell, and then when we run the cell, this is the chart that we're printed at. So you have all these values, and so your confidence interval, you've got your lower confidence interval, your mean, which is 70, and your upper confidence interval, and that being 67 being your lower confidence interval, and 73 being your upper confidence interval. So now what we're going to do is we're going to talk about question 2. So it's to simulate 25 observations from the normal distribution with mean of 15 and a standard deviation of 4. Compute 95% t-based confidence interval for the mean. So the first thing we're going to do is we're going to set the seed. So every time you run the cell, all the variables will be set to the same values to give you the same answer every time. So set dot seed brackets 1, 2, 3. And then x becomes our norm. That's a normal distribution with random points. Brackets 25, that's your observations, comma, mean equals 15, comma, SD, that's your standard deviation, equals 4. X bar becomes mean of x. S becomes standard deviation, SDX. M becomes length of x. So that's the number of variables, number of elements in x. CI is your confidence interval, becomes x bar plus c, brackets -1, 1, you're creating a vector, plus qt, brackets 0.975, brackets df, that's degree of freedom, equals n minus 1. So your degree of freedom is the number of elements, or the length minus 1, times s divided by the square root of n. And so that gives you your confidence interval. Confidence interval is 13.303 to 16.42 when you have a mean of 15. So now what we're going to do is we're going to plot these values onto a chart. So plot brackets x, comma, rep. We're going to create a vector, brackets 1, comma, n, comma, pch equals 19, comma, color equals blue, comma, xlab, that's the label of your x-axis, equals values, comma, ylab equals null, comma, yaxt equals n, comma, main, that's the title of the chart, equals 95% CI, brackets t-based reproducible. So we're going to put some lines in the chart. So we've got AB line, brackets V equals X bar, comma, color equals green, comma, line width equals 2, comma, LTY equals 2. Put another line, AB line, brackets V equals CI, that's your confidence interval, comma, color equals dark green, comma, line width equals 2, comma, LTY equals 3. Now we're going to put some text in the chart. So text, brackets, X bar, comma, 1.1, comma, mean, comma, color equals red. And then some more text, brackets, CI, that's your confidence interval, square brackets 1, that's the first element of the confidence interval, comma, 1.1, comma, lower CI, comma, color equals dark green. And then another text line, text bracket CI, confidence interval, square brackets 2, that's the second element in the confidence interval, comma, 1.1, comma, upper CI, comma, color equals dark green. And so we run the cell. And then when you run the cell, this is the chart that you get, or the graph that you get. So you can see that your mean is 15, and you've got your lower confidence interval and your upper confidence interval being 13.3 to 16.4. So now we're going to do the third practice question for confidence intervals. We're going to simulate 300 Bernoulli trials with probability of success of 0.4. We're going to compute 95% confidence interval for the true proportion. We're going to set our seed, which enables us to initialize the variables to the same values every time we run the cell. being set.seed brackets 1 to 3. X becomes R binom, that's a binomial distribution randomly sampled, brackets 300, that's how many trials you have, comma, size equals 1, comma, probability equals 0.4. P hat becomes the mean of X. SE, that's your standard error, becomes square root, brackets P hat times, brackets 1 minus P hat, divided by 300 because you've got 300 trials. CI, that's your confidence interval, becomes P hat plus C. We're creating a vector, brackets -1, comma 1 times 1.96 times SE. That's your standard error. And then you get your confidence interval. So your confidence interval is 0.33 to 0.44 because we're working with values of less than 1. We're working with percentiles, really, and so you're going to have a value of less than 1. So we're going to plot that on a graph. So bar plot, brackets, P hat, comma, Y lim equals C, bracket 0.1. So you're creating a vector, and your lower limit is going to be 0, and your upper limit is going to be 1. Color equals sky blue. Name, which is your title, equals 95% CI for proportion. Y lab, which is your label on your y-axis, is proportion. So you have arrows, brackets, 1, comma, CI, square brackets 1, that's the first element of your confidence interval, comma 1, comma CI square brackets 2, that's your second element of your confidence interval, comma angle equals 90, comma code equals 3, comma length equals 0.1, comma color equals red, comma line width equals 2. And now we're going to put some text in the chart. So text brackets 1, comma P hat plus 0.05, comma labels equals P hat, comma color equals blue. So we're going to run the cell. And when you run the cell, you see that you have the y-axis is 0 to 1, but the probability is set at 0.4. And the lower end of the probability is 0.33, and the upper end is 0.44. So that's just a graphical representation of your confidence intervals to show that to you. So now what we're going to do is we're going to cover practice question number 4. So we're going to simulate 2 independent samples. A is n equals 35, that's the number of examples, comma mean equals 50, comma SG, that's your standard deviation, equals 8. And B equals n equals 4, that's 40 samples, comma mean equals 54, and standard deviation equals 9. So we're going to compute 95% confidence interval for the difference in means. That's A minus B. So the first thing we're going to do is we're going to set our seeds. So make sure that every time we run the cell, it initializes the variables to the same values, so we'll get the same outcome every time. So set.seed brackets 1, 2, 3. So A becomes R norm, that's a randomly selected normal distribution, brackets 35, that's the number of samples, comma mean equals 50, comma SD, or your standard deviation, equals 8. And B becomes R norm, that's a randomly sampled normal distribution, brackets 40, comma mean equals 54, comma SD equals 9. So we're going to calculate the difference. Diff becomes mean A minus mean B. We're going to calculate the standard error. SE becomes square root of brackets, that's a variance A divided by length A plus variance B divided by length B. We're going to calculate the degrees of freedom, becomes min, brackets length A minus 1, comma length B minus 1. We're going to calculate the confidence interval, becomes the difference plus C, brackets -1, comma 1, so we're creating a vector, times QT, brackets 0.975, comma DF is your degree of freedoms equals DF times SE, that's your standard of error. And then we're going to get our confidence intervals. Confidence intervals is neg 7.6 to neg 0.09 because you're taking A minus B, the difference. So now we're going to plot it. We're going to create a bar plot. To do this, bar plot brackets diff, comma, y lim, that's your limits on your y-axis, equals C brackets min Ci minus 1, comma, next Ci plus 1. And then we're going to create a vector with that, which is why you've got the C. Color equals sky blue. Main is your title. Equals 95% confidence interval for differences in means, A minus B. Your Y lab, that's your label on your y-axis, is your difference. Arrows, we're going to put some arrows in there. Arrows, brackets, 1, comma, Ci, square brackets, 1. That's your first element of your confidence interval. Comma, 1, comma, Ci, square brackets, 2. That's your second element of your confidence interval, or your upper element. Comma, angle equals 90. Code equals 30. Comma, length equals 0.1. Comma, color equals red. Comma, line width equals 2. And then we're going to put some text in there as well. So text, brackets, 1, comma, diff, plus 0.5, comma, labels equals mean A minus mean B, comma, color equals blue. So we're going to plot the chart. And so we've got a 95% confidence interval for difference in means A minus B. So the y-axis is negative 8 to 0. So, and then so your mean is A minus B. And then so we've got negative 7 to negative 0. So the confidence interval is negative 7 to negative 0. And you can see that your confidence interval there. So now what we're going to do is we're going to cover the fifth practice question. So we're going to simulate 60 observations from a skewed exponential distribution. Use bootstrap sampling to compute 95% confidence interval for the median. Bootstrap resampling is a technique where you repeatedly sample with replacement from your observed data to estimate the variability of a statistic. So the first thing we're going to do in this regard is we're going to set our seed so that every time we run this cell, the variables will be set up to the same values and you'll get the same answer every time. So set.seed brackets 1, 2, 3. X becomes REXP, that's a randomly sampled exponential distribution, brackets 60, that means 60 observations, comma, rate equals 1 divided by 10, so that's telling you that it's right skewed. And then boot medians becomes replicate, brackets 2000, comma, median, bracket, sample X, comma, replace equals 2, true. And so basically what we're doing is we're employing sampling with replacement. And then we're going to calculate the confidence interval. Ci becomes quantile, brackets, boot medians, comma, C, brackets, 0.025, comma, 0.975. And then we're going to print our confidence interval. So your 2.5% is 5.87, and your 97.5% is 11.05. Okay. So now what we're going to do is we're going to plot these values onto a chart, and we're going to create a histogram. So hist, brackets, boot medians, comma, breaks equals 30, comma, color equals sky blue, comma, border equals white, comma, main, that's your title, is bootstrap distribution of median, 2000 samples, comma, X lab, that's your label of your x-axis, is bootstrap medians. We're going to put a line in there, AB line brackets, V equals CI, that's your confidence interval, comma, color equals red, comma, line width equals 2, comma, LTY equals 2. And then we're going to put some text in the chart as well. Text brackets, CI, square brackets 1, so that's your lower confidence interval, comma, par, brackets, USR, square brackets 4 times 0.9, comma, lower 95% CI, comma, color equals red, comma, POS equals 4. And then we're going to put some more text in there. So text is square brackets, CI, square brackets 2, so that's your upper confidence interval, comma, par, brackets, USI, USR, brackets, square brackets 4 times 0.9, comma, upper 95% CI, comma, color equals red, POS equals 2. So we're going to run that cell. And then when we run the cell, we get a histogram. So the histogram shows your lower confidence interval and your upper confidence interval. So your lower confidence interval is 5.8 and your upper confidence interval is 11. So that's how you calculate your confidence intervals. And in this situation, we're going to be basing our values on the median and not the mean. So that concludes our 5 practice questions for confidence intervals. So I hope that you got something out of it. My next video is going to be another topic on inferential statistics in R. So I hope that you decide to watch it.